Good morning. I'm hoping you'll learn not only from the results we have here, but some of the mistakes we made and get some practical out of all of that. Okay. Cemetery researchers frequently turn to remote sensing techniques when there are little to no trace of a burial ground visible on the surface. The effectiveness of these methods has been evaluated by numerous case studies. However, these studies tend to be conducted under optimal and under more controlled conditions than we tend to find in the field. In this study, we used a real-world situation where the adverse settings encountered at the Avondale Burial Place, also known as 9BI 164, an unmarked cemetery in southern Bibb County, Georgia. In short, records were non-existent, informant data was sparse, and we only had a rough estimate of where the cemetery was located. The grounds were over a century old. There were no surface features. And it was situated in Georgia red clay, a notoriously difficult substrate for successful remote sensing. This is location where it is in space. For those of you who know anything about Georgia, we're about 10 miles south of Macon, right almost in the center of the state. The cemetery had been abandoned, reforested, and blurred by subsurface plant and animal activities. Though these conditions made survey difficult, it provided us with a means of evaluating multiple remote sensing methods in conditions that were not uncommon in central Georgia. In 2009, New South Associates was asked by the Georgia Department of Transportation to determine the size and placement of the Avondale Burial Place. Unfortunately, the cemetery was discovered during the final planning phases of a future construction corridor and had to be relocated. The alternatives to avoiding it would have entailed moving another, and as we determined later, a much larger cemetery, or impacted one of several very large wetland areas. There were no maps or historic records of the cemetery, and previous archaeological field surveys had failed to detect it. The site came to light when a local informant recalled that there was an old cemetery in an overgrown area along a neglected fence line. His memory of it was over 50 years old and admittedly a little sketchy. The Georgia DOT opened exploratory test units and found several unmarked graves, thus verifying that the story was actually true. These units provided us with a general idea of where the cemetery was located. We eventually determined that the Avondale Burial Place likely began as a pre-emancipation burial ground and was used throughout the late 19th and early 20th centuries by a dispersed community of African American domestic and farm laborers. The cemetery held the remains of 101 individuals, consisting of 40 adults and 61 children. These decedents were placed in east-west oriented grave pits, arranged in loose family clusters. There were no grave markers present, and the ephemeral scatter of brick, glass, and shiny pottery emphasized that the Avondale Burial Place followed many African American cemetery folk traditions. These materials, however, were too widely distributed to be useful in determining or in defining the cemetery or individual graves. Our first attempt at defining the cemetery was to excavate a series of stratigraphic pits to determine the soil quality and composition. Avondale is situated squarely on the fall line. This is a geologic transition between the northern Piedmont Hills and the southern coastal plain. Along the fall line, hills of undisturbed, deeply weathered saprolite, more affectionately known as Georgia red clay, rise from the surrounding lowlands. The cemetery was positioned on one of these low weathered hills. These bulbs of red clay are not very fertile, and the farmers tend to avoid them whenever possible. The fact that the cemetery was situated in a corner of 4 land lots and the soil was relatively infertile probably contributed to why this corner had never been plowed. Soil stratigraphy in the strat pits indicated that the cemetery was surrounded by sandy loams. we observed a very clear plow zone in units right along the periphery of the cemetery, while those closer to and inside the cemetery exhibited undisturbed natural horizon development, comprised largely of sandy saprolitic clays. The cemetery was apparently left forested by the local farmers, and as a result, tree roots and animal activities blurred the top 20 to 30 centimeters of the subsoil. This bioturbation destroyed the feature definition of the upper soils, and as we later discovered, had adverse consequences on some of the remote sensing methods. You can see the edge of a grave pit coming up here, comes into the wall, goes up to the base of the root line, and at this point and everything above it, we completely lose any vision at all of where this particular grave is located. And this is pretty uniform through most of the graves we found across the site. We lost practically everything above the root lens up there. We had to get below that before we could actually physically see where this cemetery was located. The project area was surveyed in 2 phases. An initial survey of the southwestern third was conducted in spring of 2009, and the remaining area was examined a year later in spring 2010. In the intervening year, 38 graves were removed from the 2009 block. 3 methods of remote sensing, soil compaction, ground penetrating radar, and canine scent detection were employed to help define the cemetery's size and contents. The location of each potential grave defined by these detection methods was mapped. Ultimately, the true distribution of the cemetery was determined by removing all surface soils and exposing the underlying grave shafts. We placed a 30-foot wide grave-free perimeter around all graves to ensure that the true cemetery margins had been identified. During the 2009 survey, a 30 by 40 meter area was examined using soil compaction. In clay-based soils, individual particles align themselves parallel to the ground surface. When left undisturbed, they remain compact. When disturbed, however, their orientations shift and the soils become less compacted. Over time, displaced particles will shift, recompact, and realign with the ground surface. Since grave shafts are soil disturbances, the fill is generally less compact than the surrounding undisturbed soils. Penetrometers were used to measure the soil compaction in pounds per square inch, also known as PSI. Individual probe locations were spaced 50 centimeters apart, and when possible, readings were taken at about 25 centimeters below the ground surface. In this map, the green indicated extremely compacted soils, those rating at about 350 PSI, which grades into this red, there we go, that we see in locations like this, where the soil was much looser and tended to average as little as 100 PSI. Low compaction areas were found around mature trees, such as we see here, here, and here, along fence and property lines. This is an old fence line right here. And in parts of the cemetery where the Georgia original test units were located, which is this location right here. The results showed a highly irregular soil structure, but it did not reveal any potential grave shafts. We felt that bioturbation and soil recompaction had rendered this method ineffective, and we abandoned it after our initial testing. Prior to probing, scent detection using dogs trained by the Alpha Team search and rescue were employed. These animals were able to detect molecular compounds associated with decomposition, represented by only a few parts per million. The Alpha Team brought their dogs out twice. In 2009, the dogs were limited to about a half-acre area where the probe test, around the probe test tract, where we felt that the core of the cemetery originally was located. But they kept wandering off to the northeast out of the original project recovery area. This is the general location where we originally started our work. In hindsight, we now realize that the animals had actually detected the highest concentration of graves. Between the first and second visits by Alpha Team, New South excavated the first third of the cemetery and then backfilled the entire area. This was completed 7 months prior to the 2010 visit. In their return in 2010, the dogs were allowed to wander more freely over about a 1.5 acre square area. The previous excavated area was ignored during the 2010 survey. During both surveys, teams of professional handlers allowed their dogs to systematically investigate the grounds. The same 6 animals were employed in both surveys. When a dog alerted on a potential grave site, the location was flagged, recorded on a project map, and then the flags were removed to prevent biasing the other dogs and their handlers. All dogs successfully identified the location of the cemetery. Of this, 60 alerts were generated. We define positive alerts as those where the center point, which the dogs alerted us at, was within 50 centimeters of a known grave. All told, 13 graves, representing 12.87% of the true cemetery assemblage, was identified. As we learned later, the upper portions of 3 alerted graves had been impacted by previous testing, potentially bringing decay compounds to the surface and likely biasing the number of graves identified from an undisturbed setting. Among the undisturbed sample, a more conservative estimate of 10 or 9.9% of the true cemetery assemblage was detected. While these figures may seem low, they compared very favorably with the 15% achieved by Lassiter et al.'s test using modern human remains, which had been buried for only a few months. Now recall that our sample, we're dealing with remains that had been buried for over a century. We found that no relationship existed between the grave form, its size, the deposition date, decedent age or sex, and whether or not the grave had been alerted. Success of the detection method could also be based on its ability to be reliable. From the 60 alerts generated by the 6 animals, 25 were positive alerts. About half of the 13 graves identified were detected by more than one animal. As noted, however, the upper aspects of 3 graves had been impacted. To examine success among undisturbed graves, the 9 associated alerts were removed from the sample, and among the remaining 51 alerts, 16 were positive. The distribution of scent dog alerts demonstrated that most false positives, defined as alerts where no graves were found, tended to be within the cemetery limits. As noted by Duprat et al. In 2003, decay compounds in the cemetery may have been too concentrated for these animals to discriminate specific locations. During the 2010 survey, New South was responsible for false alerts along the eastern and northwestern portions of the project area. Alerts corresponded with equipment storage areas, parking, lunch, and staging areas. You'll note these are here, here, and up here. Soils from previously excavated graves were undoubtedly scattered all across the area from the team's equipment and clothing, salting the ground surface with decay compounds. We also have to note with an element of humility that the mortuary archaeologist had to leave during the canine survey because our clothing had been contaminated, and despite the fact that it was about a year since we had last been out here on our site and our clothing had been washed many times, it was still contaminated enough that the dogs kept alerting on us, and we were kind of a we haven't figured out whether or not to take that as a compliment or not yet. Okay, so when you eliminate these 14 biased false alerts, canine success rates jump from 42 to 54%. Another method we used was ground penetrating radar. This transmits pulses of radar energy into the ground and measures the velocity of the reflected signals. Signal velocities shift as they encounter buried surfaces. Unfortunately, Georgia red clay readily absorbs radar energy, significantly degrading the signals that are returned to the transmitter. Since graves in the Avondale had been deposited for upwards of a century, their contents were decomposed and the surrounding soil partially recompacted, producing decidedly weaker signals than were typically encountered in more recently deposited interments. GPR equipment requires ground contact. Accordingly, the GPR surveys were conducted last so that the project area could be completely cleared of vegetation. Results from earlier surveys were not disclosed to the GPR operators until their findings were completed. The 2009 radar survey addressed the same area covered in the compaction survey. The 2010 survey addressed an area just under a square acre in size. A GSS SIR 3000 control unit with a 400 megahertz antenna, which is capable of producing data for good resolution at depths of up to 2 meters, was mounted on a drag sled for this survey. Radar data was collected along parallel transects oriented roughly north-south and spaced about a quarter of a meter apart. In the lab, this data was translated into horizontal slices representing common depths, one of which we see here. The areas where significant shifts in signal amplitude were identified are reflected in green and orange colors. You can see a number of the green ones down here and these orange ones up in this area right here. GPR results from the two surveys were pooled, and a total of 71 anomalies exhibited amplitude signals consistent with potential graves. Using the same criteria as above, anomaly center points within 50 centimeters of a known grave were considered positive identifications. A total of 36 graves were detected. However, 4 of these overlapped between the two surveys, reducing the true score to 32 graves. When contrasted against the true number of graves, GPR was able to identify 31.68% of the graves in the cemetery. We found no relationship between GPR detection, the grave form, its size, deposition date, the decedent's age, or sex. Since 2 radar surveys were independent, our anomalies could be pooled to reveal how well GPR was able to detect Avondale's graves. True graves occurred, or true positives occurred among 36 of the 71 anomalies. Mechanical stripping included all areas where GPR anomalies were identified. Many of the false positives were in areas that were ultimately determined to be outside of the cemetery. While the source of some of these anomalies was never identified, most turned out to be soil interfaces and large roots. Recognizing that probing was ineffective, how did scent detection in GPR compare? Since the true population of the graves was the same for both methods, a simple comparison of the number of graves identified emphasized that GPR found 19 more unique graves than canine detection. Effectiveness can also be measured by the ratio of true to false positives. Since sample sizes for potentially identified graves were not equal, we employed the odds ratio statistic with about a 95% confidence interval to assess whether differences varied significantly. For those unfamiliar with these statistics, odds ratio values above 1.0 indicate a ratio in favor of one method, while values below favor another, and scoring exactly 1.0 indicates that the methods were equally effective. An odds ratio confidence interval that does not include 1.0 as a possible value is considered significantly variable enough to infer that one method's effectiveness is truly different from the other. An odds ratio value of 0.694 was calculated, favoring GPR's ability to detect more graves. However, since the confidence interval range included 1.0, and values on both sides of the ratio, the methods were not significantly different enough to reveal a clear superiority. A two-tailed Fisher's exact value of 0.38 emphasized that detection values did not vary strongly. Another way of looking at effectiveness is in the terms of how well the methods were able to pinpoint the location of the cemetery. When we examined where false positives were located, our GPR data placed a number of these on the southern and eastern sides. By these estimates, we initially defined the grave size as somewhere around 3,150 square meters. In contrast, scent dogs were predominantly either within the cemetery or along its eastern or northwestern sides. As noted earlier, these hits corresponded with areas that were contaminated by us, the archaeologists. If the spurious alerts were eliminated, the dog alerts were confined to a much smaller area. The resulting cemetery size was close to 1,000 square meters, focusing largely on the cemetery's core. We estimated the true size of the cemetery to be 1,350 square meters. While canine success rates for identifying individual graves were lower than the GPR rates, canine alerts were more concentrated within the actual core of the burial ground. We now recognize that Avondale was an unmarked cemetery with no recorded history, placed in a very difficult soil environment, and in a place where bioturbation had erased the tops off of the grave shafts. 3 remote sensing methods were used to figure out its structure. In some environments, soil compaction can be a very effective means of detection. In one particular case, we've been able to identify up to 80% of the graves in a ground truth cemetery that we worked on over in Alabama. Unfortunately, Avondale was not in one of these environments. Clay recompaction and bioturbation meant that the cemetery simply could not be detected using this method. We concluded that soil compaction was ineffective for this particular environment. GPR and canine detection, scent detection, were much more effective. In terms of defining the cemetery, we found that the scent dogs were more accurate in terms of being able to identify the cemetery's location and its general size. Once inside the burial grounds, however, the dogs had trouble distinguishing individual grave sites. As a result, there were a lot of false alerts. GPR was more effective in identifying the location of individual grave sites, but it had spuriously identified a number of non-grave anomalies which were clearly outside of the true burial area. In retrospect, we're kind of surprised that anything worked at all out at Avondale. It was a tough place to figure out where the cemetery was. The results of our remote sensing emphasized that the application of multiple methods can result in different yet complementary information. Some methods will turn out to be ineffective, particularly when faced with adverse subsurface environments. In Georgia's red clay environments, however, the use of scent detection dogs to define where the burial ground was located, which would then be followed up by an intensive GPR sweep, seems to be a more effective means of identifying where unmarked burials may be located. The use of at least 2 and optimally more remote sensing methods is advocated to provide estimates of the location and size of unmarked graves and burials in this particular part of Georgia. If I can, I want to go ahead and plug. This is a small part of this project. We had a huge amount of interaction with the descendant community. It was a joy working with these people, and the results of all this are up on our website, which has been dedicated to the Avondale burial place. And the other thing which I'll point out is that at the end of it all, in working with the descendant community, we were able to place the cemetery in another local church, which turns out to be an important part of the past. This cemetery and this church, as it turns out, had a common history that was unknown before all this, and it came out through the work with the descendants that this was a very appropriate place for it. We put these guys back into the ground in 2012, and There's been, I guess because of this, there's been a lot of collaboration that's going on between the church congregation who did not know about this descendant community and the descendant communities who are just ecstatic to find other members in the community that they didn't even know were still out there. So there we go.